In this video, we're going to complete our discussion of the frequency analysis of raw data. And we move on to something called the relative frequency. And the relative frequency is the proportion of uppercase N. Recall that uppercase N is the symbol for the total sample size. So the relative frequency is the proportion of that total sample size made up by a score's simple frequency. So the first step is always to tabulate the simple frequency, where we just simply count the number of occurrences of a particular score in those different categories that we saw in the previous video that were placed on the x-axis. And the relative frequency is essentially a fraction of the total sample size, and it's calculated using this equation right here. The relative frequency at a particular score. As an example, what would be the relative frequency for a score of 10 out of 17 on the quiz? Relative to the sample size, it's the total number of scores that were tabulated at 10 out of 17 divided by the sample size. Note here the sample size in our example is 18. There were 18 students, so don't confuse the N with the highest possible score on the quiz. N is the number of students that took the quiz. And in terms of grouping the relative frequency distribution, as we had graphed in the previous video the simple frequency distribution, we could do the same with a relative frequency distribution. So it would follow the same rules that we carried out on the previous video with the three example graphs that we had illustrated. The next step is to calculate what's called a cumulative frequency, and as the term suggests, this is the frequency that accumulates as we move through the table along the different rows. And so really what we're calculating here is the frequency of all the scores at or below a particular score. And in tabulating the accumulation, it's the accumulation of those scores. We can then move on to something that is commonly used, and that's a percentile. And the percentile refers to the percent of all the scores in our data set at or below a particular score. And it's calculated by first computing the ratio of the previous step, which was the cumulative frequency, divided by the sample size. And then to make this much easier to interpret, we just simply multiply this by 100%, so the units that we will have remaining will be a percent unit. And so let's take a look at how we would do this on this graph. So I'm sorry, on this table. And so what I've done at this point is I've already filled in all of the numbers on this table, but we'll start here on the left hand side. So recall we had placed our possible outcome scores along the first column from high to low, and then we just simply counted. We calculated a simple frequency of how many people scored 17, how many people scored 16, 15, 14, so on and so forth, and you see how those scores distribute. The next step is to summate, and so uppercase Greek letter sigma here is the symbol which means summation. So what we're doing here is we're just simply adding vertically. So we add 1 plus 0 plus 4 plus 6, continue all the way down, and we have a sigma of 18, or a summation of 18. So this number here should match the sample size, or how many people took the quiz. If it's not 18, then we've either made some sort of typographical mistake, or we missed adding a person into a particular row here. So that's the simple frequency. Moving on to the relative frequency, we'll start at the bottom, where we just take 1 and we divide it by 18. and we express that as the fraction or the simple quotient of 0.056. We then repeat that for the next row. So we take 1 divided by 18, we get the same value, the same ratio, and we see that at a quiz out of 12 out of 17. But now when we move to an outcome of 13 out of 17, we see that we had 4 people. 4 students scored 13 out of 17. So we follow the exact same approach. We take the 4 divided by 18, and we would get a value of 0.222. And we have the same, we do the same with the next level. We get 0.333 when we take 6 divided by 18, and we continue that until we have all the relative frequencies. In the bottom cell, we just add vertically. So we take the 0.056 plus 0 plus 2 plus 0.222, and we have a summation of 1.001. This value should be exactly 1. So why it is 1.001 is because of rounding errors that we accumulate as we add vertically. But this is sufficiently close to 1, which tells us that we've accounted for 100% of our entire sample. The next column is the cumulative frequency, and so we're going to start accumulating all the scores. So we start at the bottom, and we only have 1 score, and we would put a 1. Now, when we move to the next row up, we see that we have one more score at 11, and we have a value of 2. So what we're doing here is we take this score, whichever this number is, so we just transfer this number over to this column, and then we add it to the number in this column, and we place that value, that summed value, in this cell. Now we repeat as we take this number and we add it. We move up 1 row over to the simple frequency, and we only had 1 student here. We add it, and we put in that summed value in this cell right here. And so once again, we do the same thing as we take this number, we add it to the number of students that scored 13, and we see a 3 plus 4 equals a 7. A 7 plus 6 equals 13. 13 plus 4 equals 17. 17 plus 0, of course, is 17. And that will, 17 plus 1 brings us to 18. And this number here at the top should match this number down here. So the 18 is our sample size, and so as we start to accumulate all the scores as we move up, we see here that we have our accumulated sample size. The last row, the last column on the right hand side is the percentile. And so the percentile is calculated by just taking the cumulative frequency that we've just finished completing here and dividing it by the sample size and then multiplying it by 100%. So we have 1 divided by 18, and we have multiplied it by 100%, and we have 6%. We do that with 2 divided by 18, and that gives us 11, and we continue this all the way till we get to the top, where 18, of course, divided by 18 is 1. You multiply that by 100%, and you get a percentile of 100. So if a student had scored 16 out of 17 on the quiz, then they would be at the 94th percentile. Of course, we don't have any students at a 16, so we move to the students that score a 15, and as we see here, a student that scores 15 out of 17 would be at the 94th upper percentile of performance. The last slide here is, although we're just going to cover the basics when we talk about a grouped frequency distribution. So in the previous example, we had a fairly small sample size, but some research studies have sample sizes in the hundreds or the thousands. And so the grouped frequency distribution is an approach that that would allow us to convey the information for very large sample sizes. And so the challenge here is the need to balance too much or too little information. And so the key in generating a grouped frequency distribution to make a bar graph, histogram, or frequency polygon is to first determine how many intervals. And so we're dealing with data that are continuous, and so the researcher should aim to have 10 to 12 intervals of data, and based upon that, the determination of the width of each interval should follow a simple value. So anywhere it's recommended that the width should be 2, 5, 10, or 20. The bottom score within these what are called class intervals should be a multiple of the width, and all the intervals should be the same width. The interval width that I'm referring to is the width of the single bar on a histogram. So if you go back to slide number 9, you'll see that those bars are all the same width, and so the determination of how wide that is can vary depending upon the sample size and depending upon the range of the scores. So we won't go into any more detail on this, but I will follow up with an example on a grouped frequency distribution. So this ends this third video on frequency analysis.